Hello, happy Saturday, streamers. Welcome to the live stream today on Manning's channel. Very excited to be here. My name is Carl Gold, and I'm a data scientist out in Silicon Valley, California. And I have written a book with Manning called Fighting Churn with Data. So in the stream today, we're going to be doing some Python and some SQL. We're going to be talking about customer churn. Oh, you got the book. Thank you, Anthriad. I actually just got it too. Here's my copy. Finally came out. It's been a long year waiting for this book to come out, but super excited. Oh my God, it's 1 a.m. and you're stayed up for streaming and you're watching my stream. I am really honored, Anthriad. Thank you. Please follow my own streaming channel at Carl24K Data Science if you don't already. That's where I regularly stream about the topics in this book, which I suppose I should get on with and start saying what they are. I should mention, usually at my streams I spend a while kind of at the beginning just kind of talking about the background, and then in a couple of in maybe 10 or 15 minutes I'll get into the code. I'll get into the data in like 10 minutes. I'll get into the code in maybe 15 minutes. But I always spend a little while just explaining the background. What are we actually doing here? Because in data science, they say that your domain knowledge is very important. So I just like to get level set for everyone to make sure that everyone understands. So like, what is churn to begin with? The number one question. Churn is subscribers, customers, or users quitting any product or service. And I apologize if you've already seen my streams before on my own channel. This will be very familiar to you, but if not, then this is what the background you need to know. So churn is customers quitting, and it applies to all products that have recurring revenue. That includes paid subscriptions, in-app purchases, and also ad-supported products. And the churn originally comes from the churn rate, which means the percent of customers or subscribers or users that quit in a given time period, typically a month or a year. And that is special for this stream because we're actually going to talk about calculating churn rates. And we're going to be doing that with SQL if you didn't read the intro to stream starting and everything. So, but churn is no longer just a rate. Churn is also now a verb, and you can say the customer churned, or I'm churning from Netflix because there's nothing good to watch now that Peaky Blinders is over, or what have you. So you can say I'm churning, you churned, they churned. It's also a noun, and you can say things like make a churn report for this quarter, or even the customer is a churn because they canceled. And that's like the type of stuff they say in the business. So that's kind of the background. What is churn? Why should you learn churn? I'll just mention really briefly. It's the most common data science problem pretty much in the world because every company now is in this online space where they want to keep customers coming back. So by learning churn here with me, you'll learn special tips, tricks, and techniques, which never hurts. And also, if you're a beginner to data science, this is a great subject to start out with and to learn end to end, how to handle this one scenario. You'll learn everything about data preparation and cleaning and feature engineering. And so there is actually a data handling emphasis in my book and my streams because the truth is that it's really undercovered in a lot of data science education. They kind of just drop these data sets on you and say, here, run an algorithm. But really when you're on the job, it is nowhere near that simple. You have to do a lot. Well, but this week we're talking about calculating churn, not too much data handling. But anyway, this is why churn is important and why hopefully you'll find this useful. Now, what is fighting churn with data? That's the book, I should mention. It's my book from Manning Publications, finally out now. And there's a discount code shown here. You can get 40% off with that from Manning's website. It's coming out on Amazon too later in the month. It seems to hit the publisher first and Amazon later. So it's based on my experience as chief data scientist at a company called Zuora. And what is Zuora? How did I come to have all this experience with churn? I'll just mention briefly. This is not an ad for Zuora, but I just want to let you know kind of where I got started, tell you the background. So Zuora is a platform for managing subscription businesses, and a lot of companies you've heard of use Zuora, including Zoom. Talk about another word that's become a noun and a verb this year. You can have a Zoom someone, and of course Zoom as a company is the video platform many people are using now that we're on shelter in place. But they run their business on Zuora. So like their subscribers and plans and stuff, it's tracked in Zuora. I'm not going to give you a detailed description of Zuora right now. But I worked on churn with many of these companies that are on Zuora. And that's how I have a unique experience on churn, which is that a typical data scientist analyzes churn at their own company. But because I am Zuora's chief data scientist, I've been Zuora's chief data scientist, I analyzed churn at many companies, not only Zuora, but many of Zuora's customers. So that's where I got the background to write the book. And the book is really what's in my experience that I can teach you from the last few years. All right, let's see. What is data-driven churn reduction? Now this is what fighting churn with data really is. And this is like the last segment before I actually dive into some real data and code. But this is the goal of using data to fight churn. It's not really about machine learning and AI as like a lot of data science applications. So what do you do for data-driven churn reduction? Number one, I say make a product that people love. And if you make a product that people love, your customers won't churn. And you use your data to figure out what are your best features of your product without using customer surveys, because customer surveys tend to be biased. Only the people who love you or hate you answer the survey. So with your data, you can effectively survey all your customers and see what they like and what they don't like. You also market to your customers, meaning engagement marketing. Like you're supposed to be reaching out to your customers with information that they really value about the product, and not just spamming them. And again, you have to really use your data to target them and to decide what to target them about. Next, there's customer success and support. That's helping your customers. Support is when you call the company and someone helps you. Customer success is a more modern and proactive version where they're going to reach out to you, the customer, if you're, having trouble. And you use data to identify the customers that are having trouble to reach out to. So all that coming in future streams. Lastly, there's sales and pricing. You can use your data to basically figure out the best sales and pricing to keep your customers, get them value without discounts. A lot of people think fighting churn is about giving out discounts, but really it's not. That giving discounts is the worst way to fight churn because you just undermine your pricing. Once customers figure out that they can threaten to cancel and get a discount, it undermines your pricing power. That's just basically what happened to the cable and satellite companies over the last several years. They gave out so many discounts, now people just threaten to cancel to get the discount. So anyway, that's the end goal. But today we're going to be talking about just measuring churn and the churn rate. But this is the background. I always give that. All right, so what's next? So this stream is going to basically follow along with code from the book, Fighting Churn with Data, and this code is all completely free on my GitHub repo, of course. And so you don't need to actually buy the book to take advantage of all this. And there is a set of setup instructions in the repo, and I went through these setups on my last couple of streams on my own channel. This slide has the wrong channel. My channel is now Carl24K Data Science, and this is obviously an old slide that I haven't updated the channel. But anyway, we went through all these instructions in the previous weeks. There's a repo that you clone. To follow along with my instructions, I use Postgres and PyCharm. PyCharm is an integrated development environment for Python that you'll see in just a minute. And in case you're wondering, we love to debate things like R versus Python and integrated development environments versus notebooks versus Python scripts. That's what we usually do on my own channel if you're not used to it. But so happy to entertain those discussions here. So we created some schemas, which I'll show you in just a minute, and we actually ran a data simulation to create the data to show on the stream and for the book. So in the book, You need to have sample data to learn to fight churn and use all the code. But no company will give out their data for churn. So that's why for the book, I made a simulation. And in last week's simulation, I was hacking the simulation to make a better result for calculating churn. So we're doing a special simulation that's not in the book. If you want to get the simulation that I created in last week's stream, it's actually in a branch. Here, I can just show you real quick. Let's try going to show you the GitHub repo here. So this is what my GitHub repo will look like if you're checking it out. And so we made a branch last weekend, which was to calculate different MRRs. Here, this is like the multi-MRR branch. I was doing that on my stream just last week. So if you want to actually get the simulation that I'm going to be running today, you should download this branch and rerun the simulation. There's a new simulation in this branch. It's a little bit rough. I just kind of like hacked it together live on the stream last week. I did a few touch-ups, I should mention. For anyone who was following last week, I did some final fixes and improvements in the simulation. So it gives a pretty nice result, which we'll be seeing today. So yeah, just pull that branch and rerun the simulation. It's BizNet1. I'll show you in just a minute. In fact, maybe we should get to the data. This is about the time on the stream where I want to actually show you the data. So this is my slide to remind me, where is the data? If I'm still talking at this point, this means that I've been talking for too long. The data for the simulation is in a Postgres database. I'm just going to show you the schema overview here. So you can see we've got several different tables. The ones we're going to be concerned with are the subscription table and the event table. I don't know if that text is big enough for you to read however you're watching this stream. But let's see, let me demonstrate some of the data. So we've got subscription. So this, like I was saying, this was the name of the new simulation and schema that I made. It's a social network application. It's a simulated social network for churn. And I made this I called it the BizNet, because now the simulation is supposed to be about a business network where there are different subscriptions. So let's show you, let's see, I'm going to look through some of these previous SQLs. Do I have anything good here? No. Let me just do select star from subscription limit 100, and we'll take a look at the subscriptions that were created by the simulation. So you can see in the subscription table here, there's an ID for each subscription, and also there's an account number. Actually, myself is blocking the headers here. Here, I'll move this down so you can see. There's an account number for every subscription. So each subscription each account can have multiple subscriptions. Here's account 1 subscription. And each subscription has a start and end date and an amount, which we call the MRR. MRR stands for monthly recurring revenue, and that's a common term in the subscription industry, just like churn. And you get used to saying MRR if you hang around a lot of SaaS companies and subscription businesses. So anyway, so in this simulation, each account can have more than one subscription. Each subscription lasts for 1 month. So they renew and enter a new subscription record when the month is over. And there's different practices in different companies. I've worked with a lot. Some companies, when you renew each month, they extend your end date, and other companies, they enter a new subscription each month with the start and end dates line up. So here's account 1. We'll get on to account 2. Account 2, you can see they're on the basic plan. So they're only paying $4.99 a month, right? And so we've got a few different plan levels, $4.99, $4.99. Where's someone on the standard plan? Standard plan should have $9.99. Okay, account 4, well look, actually this is interesting. Account 4 started out on the Premier plan for $29.99 and then changed to $9.99 a month. Now this was actually the simulation that I was doing last week. So this is a special simulation designed for illustrating the concepts of churn. Now let's do another query to demonstrate the other data created by the simulation, which is the events table. And this will show you more about the simulation. So actually, this might not be the best illustration because here you can see each event has an account ID and a time, but we've only got a type ID on the event, which isn't that interesting. So that's because there's a type table. So I'm gonna inner join event type. Actually, let's put some aliases in here. There's an event type ID. I think we want this one. So I just want to show you what are the event types. So let's see. Let's try this now. So this, okay, so now you can see that each event actually has a name also. And so the events are for some account at some time, and there are a few different types of events. I said this is a social network simulation, so posting on the social network is one event. Hopefully we'll find some other events. They seem to be sorted by event type. Let's redo this and say, let's just sort by event time, and hopefully we'll get a little bit more variety. Whoops. Hey, that's order by. This is SQL. See, this is what's fun about live streaming. You can screw up and it's just like, oh well, this is what everyone does all day when we're really working. All right, so now we've got some slightly different events. We're seeing like events. Need to like move this over a little bit so you can see more. So there's like events, there's message events. So the social network has a few different things you can do. And remember, this is all simulation. This is not a real social network. It's impossible to get companies to part with their churn data or their, the real data from their companies. So that's why for the book, we're doing a simulation. So you can have all these events on the social network: posts, messages, likes, replies, ad views. So the social network has ads too, and you have to pay. Man, this social network is pretty tough. But so this is the underlying data for fighting churn. Usually this is what most companies start out with. You've got your subscriptions, which is how much people, what people have signed up for and for exactly how long. And then you've got your events. And the subscriptions, you might notice, are typically, small data, because you only have like one subscription per customer per month. But your events are very likely to be big data, because every account can have many events every month. So that's the background, that's the data that was created by the simulation. It's just a big table of events and subscriptions. Let's say how big, just so we can know. Let's do a quick select count star. Whoops. So in this simulation we created, it's taking a while to count. Must be a big number. Is it even working? Remember, I did this on my last stream and I was waiting and waiting and I thought it wasn't working, but no, it's still running. I gotta be more patient. Count those events, Postgres. The table's not that big. All right, let's see. That looks like 17 million events. Okay, so it's kind of medium data. It's not enormous, but so there you go. So we generated 18 million events, and how many subscriptions? 55,000 subscriptions from this simulation. So that's the underlying data that we're working on. And if you ran the simulation that comes with a book, you'll have similar data in your own Postgres schema. All right, so what are we actually going to talk about today? I'm going to jump back to my slide deck now that I've actually demonstrated where's the data, showed you what the data looks like. We're going to get into that data more now for the rest of the stream. Let's talk churn, because we are here today to learn how to calculate churn. And this is the concept of churn in the best diagram that I could think of. I didn't know how to make. They said when I was writing the chapter, you have to illustrate the concept with a picture. So this is the best I came up with. I hope you like it. Each circle in the picture represents the business that you're measuring churn for at one particular time. And the size of the circle represents how much customers you have. And that could be in counting the number of customers or the amount of money that they pay. And you can measure churn in either the amount of money or the number. That's why I say here it's like customers with a dollar sign. So you could be counting customers or you could be counting what they pay you. Remember, in this simulation, as I just showed you, if we go back a few queries, remember, people are paying different amounts here. So what they pay and the number of customers will not be the same. But that's an important theme throughout today's stream. Anyway, so if you imagine time moves forward and your circle moves and maybe gets bigger, which is what's happening here, some of your customers are going to quit, and those are the churn. So that's this top part of the circle. Those are the customers that you lost. And then some of the customers are the ones that you keep, and that's called retention. So retention is the opposite of churn. Well, in considering your existing business, if you don't churn your customers, they're retained. There's something else, which is acquisition, and that's you getting new customers. So acquisition happens, but it's not really related to churn, as you're going to see throughout the stream. Now, if you consider what the circle at the start, which is your business at one point in time, or it represents your business at one point in time, you can see that churn plus retention makes the whole circle. So that gives the equation churn plus retention equals 100%. So churn and retention, when you're talking about the rate of churn or the rate of retention, they're just two sides of the same coin. It depends if you want to see the glass as half full or half empty. Conveniently, you can calculate either retention or churn and get one from the other. So retention is 100% minus your churn percent, or churn is 100% minus your retention percent. So that's the churn concept, and that's what we're going to be calculating for the customers. So how do you calculate it? Here's the chapter plan. Now, I mentioned we're going to look at different definitions of churn based on either money or people. The first version of churn we'll look at is called net retention, and that's actually based on what the customers pay. After that, we'll look at customer churn or subscriber churn, which is basically the standard churn that most people think of, and that's a customer-based churn. Then we're going to look at another version of churn based on money, which is revenue. Then we're going to look also at activity churn, which is churn based on events. So remember, we have the events in the database, and you could have churn based on those too. And then lastly, we'll look at, if we're not all burnt out on the stream, it might be another hour before we get to this, we can look at converting churn between different time periods. And that'll make more sense, but that's about monthly versus annual. So I do want to mention also, I'm happy to take questions, comments, if anyone finds anything unclear at any point during the stream, feel free to throw it out on the chat. And also I do want to mention and remind you, I do have my own stream at Carl24K Data Science on Twitch, shown at the bottom of the screen, and that's where I stream more about this same subject. In fact, I'm streaming the entire book. We're only in chapter 2 right now, but over the next several weeks, maybe a few months, I'm going to stream the entire book. So please join me on my own stream later. So now let's dive in and talk about how we actually calculate our first form of churn, which is net retention. So this is illustrating a toy problem of net retention. The basic idea is shown at the bottom of the screen here. So net retention rate is the revenue you retain from the start divided by the revenue at the start. So you've always got a start period and an end of your time period when you're talking about churn. So in this toy example, we start on January 1st and we end on February 1st. We start with 5 customers shown on the left, and some of them are on standard plan and some of them are on premier plan. I don't have any basic plan in this toy problem, but we've got basic plan in the simulation too. Now in that 1 month, one customer churns. That's what the red X here is. So on February 1st, customer 2 is gone. Suppose we add 2 new customers, shown here at the bottom, customers 6 and 7. Now that's nice, but adding customers doesn't affect churn. Churn is only based on the customers that leave. But in net retention, it's based on, can I please switch off the background music? Oh, not into the background music? Is it too loud? Maybe too distracting. How about I turn it down? Let's see. How's that? Can I do it with quiet background music? It kind of helps me actually keep up my energy. I can hear it in my headphones, and I hope it's like just a quiet. So let me know if the background music is still annoying. Anything for the viewers. I can survive without music for a little while. Let me know what you think. All right, so still explaining net retention. Let's do the calculation. So the amount they had at the start was $89.95, which you can see if you add up these customers here. And the amount that was retained is shown highlighted in green. So we retained $9.99, $9.99. Actually, this last customer had an upgrade, customer 5. So they went from $9.99 to $29.99. And that's actually an interesting thing about net retention, that the upgrades count because it's the money you retain from your retained customers. So if a customer is paying you more at the end than they did at the start, it actually helps. So here we get the net retention rate is 79.96 over 89.95 or 89%. Now, if that's the net retention calculation, it looks kind of like a pain to do that on your customers, but let's think about how we're going to do this as programmers and data scientists. Well, we're going to use SQL, because doesn't this just look like a SQL calculation? You've got one table on the left, your customers at the start, and another table on the right, which is your customers at the end. And the retained revenue can easily be calculated by joining the two to see all the customers that you've retained. So that's how we're going to calculate net retention. And I think we're going to be ready to go back to the code now. So like I said earlier, all the code for the stream is available on my GitHub repo, carl24k/fight-churn. And we're going to look at listing 2.1, which means it's chapter 2, listing 1, the first listing from chapter 2. And let's go take a look at it. It's a SQL listing, as you can tell. So now I'm going to go to PyCharm, which is the code editor. It looks like I've got a bunch of random stuff open here. Sorry, I didn't really clean up before my stream. This is actually left over from calculating. Oh, here's the right SQL. I did have something open. Let's see. So this is the SQL for net retention. I'll show it to you briefly, and then we're going to run it. Let me get up to the top. So you might notice here that I use what's called common table expressions to do my SQLs. And that refers to this style of writing the subqueries. So within each curly brace, you've got another subquery. And I like using common table expressions, especially for teaching SQL, because it lays it out in a really clear order. I don't know if you know if you're familiar with older styles of doing subqueries, they're all nested and a lot harder to read. So this is great for teaching. It's also great for writing your own code to make it more self-documenting. If you write a hard query and come back to it a year later, it's much easier when it's written this way. So there's one common table expression at the start, which is actually just some constants. Let me break this line here. So there's a start date and an end date, which I set in the first common table expression. And it uses bind variables. So that's what is shown here. It starts with a percentage, and those are going to be filled in by the code that runs the SQL at the time it's run. And we're going to run it in just a moment. So the way we do the calculation is actually just like in the toy problem I showed you a minute ago. We create a table of start accounts by a select. So there's really only one subscription table, but we're going to create our own temporary table of the accounts that are active at the start of our churn calculation. Now, you get the accounts that are active at the start of the churn calculation using this join shown here. So in order for an account to be active, the subscription start date, that's what happens when you're live streaming. The subscription start date has to be before the start date of the calculation. That's why these are the start accounts. And the subscription end date has to be after the start date of the calculation. Whoops, still didn't correct that typo. Sorry, people. Live breaking my code. This is not live coding. This is live messing up my code. But anyway, here we go. So start date of subscription before start date of calculation, end date of subscription after end date of calculation, or you could have a null end date. That's one way to represent that the subscription doesn't end. Now, if you recall, my subscriptions do have an end date. If you look in the database from the simulation, all of the subscriptions have an end date. But I wrote this code to work with other ways of storing subscription records. And in fact, some of my case studies that I used for the book actually had no end date for subscriptions that hadn't ended. So that's why you'll see throughout the book, when I'm selecting subscriptions, there's this option, okay, or end date is null, which means the subscription is active. And when they cancel the subscription, that's when they enter the end date. So if the subscription has not ended, there will be no end date. Anyway, this query will give you all the starting accounts and how much they're paying. Another little detail is that I group by the account ID and sum the MRR. And remember, the MRR is what they're paying. MRR is like $4.99, $9.99. Here you go, back in the data, $4.99 or $29.99, $9.99. So that's what the MRR is. And so why do I sum the total MRR when it looks like in the data there's only one subscription? That's because in many real subscription services, the customers can have more than one subscription. It's as simple as that. And these are typically add-on products or extra products because the most successful subscription companies are going to sell multiple subscriptions to one person, or they're going to sell extras and add-ons to the subscription. So that's why throughout my book, I use this group by, and in particular, the case studies through the book, or if you're just joining the stream, this is the book, Fighting Churn with Data, but the case studies throughout the book include 3 different companies, and those companies were all business-to-business products that sold multiple subscriptions to the same customer whenever possible. But the simulation is just one subscription per customer. And so you might be wondering, but that's why I write the code in the most general form to support your real use cases. If you're a user of this code, in a real company, you might have more than one subscription. Hopefully you do, because that means you're upgrading and upselling your customers and finding new ways to provide them value. All right, so I think I beat to death the start account query shown here. And next comes the end account query, which is really the same, except the condition for an account to be active is that the start date should be less than or equal to the end date. I think we should actually start maybe running this code. Let me actually run it, and then we can actually bring it into the SQL editor, the SQL GUI that I'm using, and we can actually run the SQL live. Now, I have a bunch of configurations created to run the code here. You can see these ones that I have. This is listing 2.1. Let me just show you how I do this. If you watched my stream last week or the last 2 weeks, I went through all the setup steps. But basically, I'm running the wrapper program for Fighting Churn with Data is this program, run churn listing. And then I say chapter 2 listing 1 with the parameters, and I'm running it for my own schema, BizNet1, which is the simulation. And so this is a saved configuration that I have in PyCharm, and that's what I'm going to use to run the listings. And there's details about how to set this up in the README on the GitHub repo, or watch last week's stream where I go through it in plenty of detail. So let's see. I'm actually going to run it now because it will print out the query as it goes. So it says, it'll print out the query in particular with the bind variables entered. We'll look at the result in a minute. First, this is my query, and you can see that it's put in the date, a start date and an end date for the bind variables that had been declared in the code. And that's what the wrapper program does. Let's actually take the SQL over to the GUI SQL editor here. And I'll go back up. And let's make sure I moved it over here correctly and I can execute it. All right, so that's working. Maybe I should make this font a little bit smaller. Let me know if the font gets too small. I just feel like it would be better off to see more code in the screen here. So this was the date range select, this was start accounts, and this was end accounts, which I already showed you. I actually do feel like this would be easier to read a little bit smaller. I mean, I don't need giant font. So to demonstrate the SQL, I'll just like delete this part here and say select star from start accounts, just to show you guys what happens here. So the first common table expression results in this table summarizing the accounts at that point in time. If you can read it at the bottom, there's like 10,000 rows, and these are all of their different MRR values. Or we can do it from the end accounts, and well, it's mostly the same accounts, right? It's only 1 month later. Looks like 10,800 accounts. So there's around 500 new accounts at the end of the month. But remember, the added accounts don't actually influence the churn calculation. All right, let's go back. And now let's look at the next part of the SQL, which is really the ultimate step, which is the retained accounts. So we do an inner join on the start accounts and the end accounts on the account ID. It's as simple as that. And that's basically the calculation strategy that I illustrated in the toy problem. So if we do this part of the SQL, and we can just say select star from, this is what I'm demonstrating is a great way to debug your common table expression SQLs. Oh God, someone's spamming on on the channel. We got to report these people. So if anyone can report that LSinjin003, they're spamming Manning's channel during a live stream. That's lame. So executing the SQL, well, the retained accounts actually just looks like the start accounts and end accounts because it's really an amount, just the accounts and an amount of money. But what you can see here is I'm actually using the MRR from the ending. This is E for the ending accounts. And that's because you actually use, I'm going back to the original SQL here. Well, here it is. You actually use the MRR at the end. That's your retained MRR. So the next parts of this SQL, listing 2.1, like scroll this down, is to select the starting MRR, which is actually just for illustration. No, it is not just for illustration. It's for the denominator. You need the starting MRR because the retained MRR is what you're left with at the end divided by what you started with. So this is the retained MRR. And in these two steps, I'm just making it convenient. Like these group bys are kind of unnecessary. I could have done them in the final select shown here at the bottom. The final select gives you, this is the net retention formula, retained MRR divided by start MRR. This is net MRR churn, which is, because I said churn is 1 minus MRR, you can select a churn rate from your retention rate just by doing 1 minus the churn rate. And then we do the start MRR and the retained MRR, just to illustrate. So now let's look at the entire SQL put together. Here's the result. Whoops, I messed it up. Because what did I do? How did I break my own SQL live? Let's try this version. I'm trying to go back to the original. All right, here, I don't know how I broke it, but here's the fixed version. So what we get in the end is that the MRR retention rate is actually very high, 99%. So that's almost 100% retention. Pretty good, right? Sounds good. And the churn rate is thus here less than 1%. And here you can see the underlying numbers. We retained, we had $120,000. Hey, this social network's a pretty good business, $120,000 a month at the start. And then we retained 119,272 at the end. But remember, this is all just a simulation. You know, it's not like real money here. But yeah, so this illustrates the complete SQL. Anyone have any questions on that? Please let me know in the chat. Tired of looking at that, you know, spammer. I'm just going to tell them to go away. No spam, please. So anyway, let me know if you have any real questions or comments on the code that I'm showing you. But that kind of covers the net MRR retention. Let's go over and see. Let's go what's next. So that was listing 2.1, and that's how you calculate net retention with SQL. Let me make a few closing comments on net retention, on how you use it. What is good about net retention? First, it's simple. Like I showed you, you calculate it with an inner join, and that's simpler than the other churn calculation methods you're going to see in the rest of the stream. If all customers pay the same price, or if they don't pay, then the standard churn, which you're going to learn next, is actually 100% minus net retention. It's actually the same thing. So if all your customers pay the same thing, you can calculate the churn with net retention and, you know, you're good. Now, if you have multiple prices, as you saw in this simulation, it's a fact of net retention that upsell cancels churn because it's based on the customers that stay and how much they pay. So that's actually kind of a distortion of your churn, and that's the reason why net retention is not the end story of calculating churn. So this distortion of canceling your churn with upsells is kind of bad for churn fighting because it obscures what your true churn rate is. But this distortion is actually good if you want to report your churn to investors. Why? It makes your retention sound higher than it is based on your actual churn rate. So if you actually look, a lot of public companies, and I mean companies like Netflix or, I don't know, Disney Plus, companies that report their net retention in their filings, often report net retention because it's kind of a more benign sounding version of your churn rate, because you've a little bit obscured what your true underlying churn rate is by canceling it out with your upsells. Now that's great if you want to report to investors, you want to show the glass half full, and also net retention is a really important business metric. But if you're in a company that's trying to fight churn, if your job is fighting churn, then actually the distortion caused by the upsell canceling churn is not really that good. So that's why there's other definitions of churn that we're going to get to next. So that was net retention. Going back to the chapter plan, I'll show you here. This is where it's all going. Next, we're going to do the standard customer churn. People just call it churn or customer churn. If they don't say what kind of churn they mean, they usually mean the standard churn. I do just want to remind you, everyone who's watching, if you don't already follow me, please follow my own channel, Carl24K Data Science. Also on Twitch, I do my own data science streams. It's shown here at the bottom. And that's where I'm going to be streaming the entire book from beginning to end. This is just in chapter 2. So I'm still in chapter 2 of Fighting Churn with Data. But that's where this is all coming from. So that's why I say chapter plan. And future chapters will be on my own stream. All right, now let's talk customer churn or standard churn. This is a toy problem for customer churn. And it has the same setup as before. I've got a table of customers or a list of customers at my start date, and then my customers listed at the end date. Here I'm not showing how much they pay because how much they pay is actually irrelevant for the standard customer churn. They call it the customer churn because it's based on the number of customers, which, as I mentioned earlier, is one of the different ways you can view the size of your business or churn. So in standard customer churn, well, illustrated here, you look at how many customers churn and divide that by the number at the start. So the churn rate is the number who churned divided by the number at the start. And again, you divide by the number at the start, not the number at the end. Hey, thanks for the follow. Someone just followed me. It's actually not showing. Oh no, it is showing. Yeah, it's showing from my own stream that someone is following. Or maybe they followed Manning. I can't tell. I'm like I'm signed into Manning's stream here. Anyway, thanks for following Manning if that's what's going on. They're awesome, an awesome book company. Anyway, back to the churn toy problem. You can see one customer churns, and so that's the numerator of the churn rate. So in this case, the churn rate is only 20% because 1 in 5 customers churned. And 2 customers were actually added. Again, another follower. Good to see you following. Hope you enjoy data science and Manning books. So 2 customers were added, and I'm showing them here, and just to make the point that they don't matter for the churn calculation, because churn is only about the number who quit. Now, how are we going to calculate this? Well, let's think about it. We've got 2 tables here, a table of customers at the start and a table of customers at the end. But actually, an inner join is not going to directly calculate. Oh, Detox Mango, you don't know why you unfollowed me. Oh, sorry you unfollowed me, and I'm glad you refollowed me. I actually remember talking to you a few times, so glad to have you back. See you as a follower. I'm doing the same stuff, so you can always catch up on whatever you missed on the stream. All right, let's look at how we actually calculate the standard customer churn. And that is using a different type of join. So we're going back to the concept of churn here, the 2-circle concept, where the top circle is your starting customers, the bottom circle is your ending customers. The intersection in the Venn diagram is the retained customers. And then this little downward facing crescent at the top is the churn customers. Those are the customers that we lost. And we're ignoring the ones we acquired for now. But I demonstrated earlier in today's stream that retention is the inner join of the starting and the end customers. So what does that mean the churns are? Actually, the churns are equivalent to a left outer join. And I'll briefly explain outer joins for anyone who hasn't already learned them in SQL or SQL. In an inner join, you take the rows that match your join condition in both tables. So inner joining start and end accounts gives you the accounts that are in both the start and the end. Now an outer join, a left outer join, gives you all the rows in the first table, and then if you match the rows in the second table, you get the result of the second table, but you still keep the row from your first table, and you'll just get nulls in the position of the second data fields that you try to join on. But for churn, we go one step further, and we actually, as you can show here, you put in a where clause that the ending account had a null. So that means it was a start account that did not match the end accounts, and that's why those are the churns. So that's why outer joins, in particular left outer joins, are used for detecting churn customers. Also, if you think about it, if you're thinking ahead, you can do a right outer join to find your newly acquired customers, but we're not going to do that today. It's like a separate exercise, is the acquired customers. All right, so we do an inner join for retention and a left outer join for standard churn calculation. So now that must mean it's time to go back to the code. This is the fun part. More fun anyway. So let's see. Let's go to listing 2.2. Now, if you haven't seen the code from my book before, if you go to the top level, there's a listings folder. We're just going to go down into the listings folder and then go into chapter 2. And I'll go to listing 2.2, which is the churn rate. I'll do what I did last time. I think it actually works a little bit better. This is the version of the code that's saved with the bind variables. And when I execute it, I actually already have a configuration to run listing 2.2 because I was doing this a bunch in last week's streams. Let's see, listing 2.1, 2.2. Here we go. Run listing 2.2. And it just has the parameters chapter 2, listing 2. And if you just joined and you didn't hear me at the start of the stream, I'm doing a special simulation, which is actually in a branch at the GitHub repo. This is not the standard simulation from the book. This is a special simulation that I created just for the live stream. So that's to make it sound exclusive and cool. I don't know if it's that cool to have a special simulation. Pretty dorky, but hey, gotta love it. Okay, so I'm just gonna run the SQL first, and as usual, when you run a SQL listing from the book, it prints out the SQL before the result, and you can see it prints out a churn rate as expected. But what I'm gonna do again is I'm gonna copy the SQL that has the bind variables included already. And by that I mean in this top position, I put in the actual start and end date that I want to use, whereas in the code from the book, it's written in a general way here with bind variables. And you'll see this throughout the SQL for fighting churn with data, that there are bind variables. Is this IntelliJ? No games foretold men? Wow, cool name. Yes, this is IntelliJ. This is PyCharm. Wait, is it? No, it's not IntelliJ. It's PyCharm. Isn't PyCharm is from JetBrains, if I'm getting this right. IntelliJ is from someone else, right? So this is not IntelliJ. Yeah, I've got PyCharm going here. And why do I have PyCharm? I don't know. That's just like what I've been used to. I learned PyCharm before I learned the others, so I use PyCharm. Some people on my team use VS, and I know from discussions on the stream, VS is another very popular IDE for Python. But I'm not a rapid technology embracer. If you get to know me, I learn the technology and I just I can't be bothered changing because I'm focused on the science really. And the science is the technology is just a tool. So I change tools when I need to because I'm always changing science. I'm always doing new science. Anyway, I was supposed to be explaining the SQL. Let's get back to it. So just like in the net retention SQL, which I explained earlier in the stream, we have a common table expression for the start accounts. But now I'm only selecting the account ID because how much they pay doesn't matter for customer churn. Wait, is this my new SQL? Yeah, this is it. Let's execute it so we get the result. Whoops. Hey, it's broken. What happened? At or near account ID. How did I break it? It is working. Churn rate. Yeah. Okay, this was working. That was just brain freeze on the SQL editor here. So we select start accounts using, again, the criteria is that the subscription start date must be before the calculation start date, and the subscription end date has to be after the calculation end date. Now, why did I use the distinct clause? That's in case an account has more than one subscription. As I explained earlier, this code is written to support the case that one customer could have multiple subscriptions if you have more than one product or if you have add-ons for the same product. So end accounts are selected in the same way. And now comes the crucial common table expression, which is the churned accounts. I'll show you this one. So this is the churned accounts is the outer join that I just described. So we do start accounts, left outer join, end accounts on the account ID. But then we have the where clause that we want the end account ID to be null. Let's just make this select star so we can we can see what the inner join looks like. So you can see in this join we've got an account ID, but because we had the where condition that the end accounts is null, that's why you're only seeing the start account IDs. So let's see. Try to get back to the original query to keep illustrating it. So this was the crucial left outer join for doing the churn calculation. And then after that, the rest of this is just kind of like tabulation and bookkeeping. So we count the number of accounts at the start and count the number of accounts at the end. And then the final select shown here is the number that churned divided by the number at the start, which is what I explained at the very beginning when we looked at the calculation strategy. So let's see. Whoops, I messed it up again. How come every time? Oh, I know why it keeps dying. It's because I've selected this and it thinks that I'm trying to execute end start as my query. Oh God, now, yeah, if I don't select anything. So note to self, this is one of those SQL editors. This is Postigo. It's like a little Macintosh, Mac I said, SQL toy or tool. And it's actually convenient for streaming because I can make the font really big. I actually only use this when I'm streaming, but it looks very visible on the screen, I think. And I can make very big font to make sure that everyone on the stream can see it. Like that. This is probably too big again, but it's got great size control. Okay, so finally for this case, we select the churn rate, which is the number that churned divided by the number at the start. And then we can also select the equivalent retention rate, in this case, 94%. And then also I'm showing the number at the start and the number that churned just for illustration. So 586 churn out of 10,327 customers who are there at the start. Now, to compare that, let's go back to the net retention really quick, if I can find it. Let's see. Back. Let's see, is this net retention yet? Somewhere back here, I did net retention. And we will get there eventually. I hope, or you guys are going to kill me. What if I use this history thing? Maybe this was it. Is this net retention? Nope. Let's see. All right, this is the net retention query. So we had 94% retention rate and 5.6 churn rate from the standard churn. If we do net retention, we had 99% retention and less than 1% churn. So you can see actually for the same data, the net retention rate here was higher than the churn rate. So let's see, we'll talk a little bit more about that. I want to get back to my churn query. Is this the churn query again? Yeah, so here's my churn query again, 5% churn. So let's talk about it a little bit more. I'm going to go back to the slide deck since I think we've beaten that code to death. I don't know if anyone has any questions on the churn rate SQL. Happy to entertain them in the chat. So let's talk about what you do with a churn rate. Now, first note, the churn rate does not reflect upsell or downsell. It ignores price differences. Now, it's good to ignore those price differences when you give your customers discounts that expire. That's what I mean by transient discounts. Because if you gave out a bunch of discounts one month, and then they all expired the next month, then all those customers, what they pay would increase. And that would be like an upsell. And that would, if you were using net retention, that would actually offset your churn and kind of, mess up your churn calculation. So it's good to ignore price changes when you have a few prices that are not too far apart. Like if you had like $5.99, $6.99, and $7.99, you don't really want to take into account those prices either. On the other hand, ignoring prices is kind of bad if you have a wide range of prices. And so by a wide range of prices, actually this business network simulation does have a wide range of prices on a relative scale. Your lowest price is only $4.99 and the highest price is $29.99. So the highest price is 6 times, the smallest price, $30 compared to $5. So that means one customer on the premium plan is worth 6 customers on the basic plan. And when you have a situation like that, that's when it makes sense to actually use a churn calculation that reflects the price differences. Now in enterprise software, which is what my company is, Zuora is an enterprise software company, the high price is like 100 times the low price. So then you really don't want to count all your customers equally. So that's why we're going to do one more version of the churn rate. Well, there's actually more than one more version, but the next version of the churn rate, which I think I have another slide for that, is going to be called revenue churn. And revenue churn is when you're going to actually do churn in terms of revenue and not customers, but it's going to be an improvement over net retention. how is revenue churn going to how do we improve net retention? I said the problem with net retention is that upsells cancel your churn. So revenue churn is going to only include the downsells. And the idea of that is that, let's see, how do I move myself out of the way? Here, if I move over this way, I can actually stop blocking the text. That's a good thing to note. This is my first week with the new camera, so I'm figuring out how to how to do the stream, but getting the swing of it. I love it actually. I like floating over the background like this. Looks way cool. Anyway, so revenue churn, we're just gonna do churn dollars and downsell dollars, but no upsell dollars. So let's look at a toy calculation example shown here. So once again, we have like the customers active at the start on the left, and we're starting out with $89.95. Then we also have our customers that are active at the end in another little table. And this is, as you can see, this is a continuing example from earlier in the chapter and earlier in the stream. So in this 1 month time period, shown by the simulation, one person churns and one person downsells. One person upsells, that means they go from standard to the premier plan, and 2 new customers sign up. So the revenue at the start in this toy example was $89.95. We lose $20 from the downsell. That's this customer 4 who went from premier to, well, it says premier, but you can see it goes to $9.99. Man, that's probably a typo in the book too. I gotta check that. It says premier when it should be standard. Anyway. Nice to find my errors live on stream. Then we've got the churn. So we lost $29.99 for the churn. So in this case, we lost $49.99 in the month out of our $89.95 starting amount. So we've got 56% churn in this month for the revenue churn. So that's how we're going to calculate revenue churn, and it's the most kind of punishing churn calculation, because it only includes the downsells and no upsells. And of course, no acquisition. Like these newly acquired customers 6 and 7, they don't enter into churn, because churn is all about your unhappy customers leaving. All right, so how are we going to do this in a SQL? It's just going to be a little bit more complicated version of the earlier one. So let's go to the code and we'll look at listing 2.4. Once again, all the listings are in the listing folder, and under the listing folder, we've got chapters. So this is listing 2.4. Actually, I don't even need to show it to you here because I already have a configuration saved for it. So I'm just gonna hit the run button, and we should see the revenue churn calculation spitting out down here. So here's the results at the end. I will go up, and as before, I will copy the SQL from the printout into my friendly GUI SQL editor so I can illustrate it for you. So here you can see actually at the start that the MRR churn rate is higher. It's around 9%, but let's see how we get to that. Just like in the other churn calculations, we have a start and end date that's set in a common table expression at the top. Those are like the parameters. If you imagine this SQL is like a function, these are kind of the parameters, but they get set by bind variables when you call it. So the start accounts are selected in a table, and this is actually just like the retention churn case that we saw earlier. We sum the total amount that they pay, which is the total MRR. We do the same for end accounts. And remember, you find the accounts active at the end date by looking for subscriptions whose start date is before the calculation end date, and subscriptions whose end date is after the calculation end date. That's why we've got S for subscription and D is for the dates of the calculation. Next, we do a churned account query just like we did in the standard churn SQL, only now we've got the amount they pay. So let's actually delete this part. As I explained earlier, this is a great way to see what common table expression SQLs do. Don't be shy to just delete one and select the result from one of the intermediate tables. So here you can see what we get from the churned account common table expression. It's actually just the accounts that churned. And you can see that they churned by looking at the account ID in the ending table. Whoops, I got to put that into my aggregation. Trying to illustrate the SQL for you. And like I said, it is good to actually just get into these SQLs and hack around with them to make sure you understand them. So definitely want to encourage people to get hands-on with the code in the book. I worry that because I gave the wrapper program with a book, no one's going to get their hands into this. But I know the more motivated people will. So in the churn account table, they have a start account ID, no end account ID because of this where clause on the left outer join between start and end. We also have how much they paid at the start, which is total MRR. So that's the common table expression for the churned accounts. Let's see if I can go back to the entire SQL here. All right, if that's right, yeah. So here's the entire revenue churn query. But the next important part is actually the downsells. Because if you remember from the strategy, let's go back to the strategy, we have to add the churn revenue, which is the amount of money from those customers who churned, and the downsell revenue, because that's considered part of churn for revenue churn. So going back to the code, this is the downsell subquery or common table expression. So we've got, it's actually an inner join, just like in the revenue churn query, because the downsold accounts are retained accounts. But it's those retained accounts where the ending MRR is less than the starting MRR. So this where clause is the key to selecting the downsells. And this is actually my own kind of practical definition of a downsell is any customer that's paying less at the end than they paid at the start. And if you have just 3 plans, you can define your downsells in terms of the plan level. You just have anyone who ended on the standard plan and started on Premier, or ended on basic or started on standard in Premier. But it's actually simpler if you just do it in terms of MRR. And that's also good because you could have customers with multiple subscriptions, which is always a possibility. Excuse me, had to clear my throat there. Anyway, so this is the downsell query, and here let's take a look at the downsell query. We'll say select star from downsell counts, and let's also just for illustration select the starting and ending MRR, which is what these two ought to be. So this will be all our downsell accounts, and we should see that they all start. So these are the accounts that started at 29 and ended at $9.99, and their downsell amount is 20. If we keep going, we should see some other downsells. Let's see. Any downsells to 4? That would be a little bit weird, actually, if there's none. Huh. That is interesting. Now I'm learning something that I don't know about my own simulation, which is that there are only downsells from Premier to Standard, but none from Standard to Basic. Well, maybe those people just churn. Anyway, this is just a simulation, so pay no mind. But that's what you can see all these people did downsell. So that's the idea of the downsell accounts, is that it's only those accounts that actually paid less. So going back to the entire query, to do the final query, I do these intermediate steps of summing the amount of MRR from the churned customers here, and also summing the amount of MRR from the downsells here. And then lastly, we put them together and add up the churned MRR plus the downsell MRR, divide that by the start MRR to get the MRR churn rate. Whoops. Once again, screwing up because I've got something selected when I'm trying to run my query. So now we see the MRR churn rate is actually 9%. And that's from starting MRR, looks like 120,000. There was 5,800 in churn MRR and also 5,000 in downsell MRR. So so the downsell component in this case is almost equal to the churn component. So downsell can be very significant, although of course this is just a simulation. It's not actually a real business or real data. So that is the MRR or the revenue churn query. And you can see here that the MRR churn rate was higher than the regular churn rate. Let's see if I can go back and find the regular churn rate query. So here from the regular churn rate query, we had 9% from MRR churn, and we've only got 5% from the revenue churn query. And then if you remember, going back even further, let's see, to the net retention query, then, whoops, that's not the net retention query. Go back even further, backer than back. Let's see, it must be, this must be the first one. So this is back to the net retention. Now we've actually got only less than 1% churn. So that shows how the impact of including upsells versus not including upsells and downsells. So let's see. To explain that more, let me go back to the slide deck. Let's see. All right, here's the relationship that I was just trying to explain between these different measures of churn. So we've gone over 3 measures of churn so far. And what we saw is that the revenue churn, the last one I just did, which includes downsells but not upsells, is the greatest. So revenue churn is the most pessimistic. It includes downsells but not upsells. Customer churn is in the middle because customer churn, it's kind of neutral. It actually ignores the amount the customers pay. So every churn is equivalent to every other churn. Now, net retention is kind of the most optimistic or positive reflection of churn because it includes upsells and not just downsells, and it allows upsells to cancel churn. So that is the relationship between these churn measures in theory, but is that what you actually see in practice? Interestingly, not. In real life, you'll find a difference, and that's that customer churn is usually greater than revenue churn, which is really weird because I just told you that revenue churn is more pessimistic because it includes downsells. But there's actually a fact that you find in any real business, which is that big spenders churn less. That may be surprising to you. We can go more into it. I explain it in a lot of my other streams and presentations. But the thing is, customers who are on a Premier plan tend to churn less because they're the customers that like the product the most in the first place. So you're actually kind of pre-selected. Your best customers are on your Premier plan. So that's why you actually find that the Premier plan customers churn less, and normally you get customer churn lower than revenue churn. And you still have that net retention, upsell, cancels, churn. So that's the most optimistic or the lowest churn rate. You can even have negative churn from net retention. That's when your net retention is greater than 100%, which means that your upsells are even more than your churn rate. So anyway, so that's what you find in real life calculating these different churn measures. All right, looking at the plan, we're making good progress. We're now up to activity-based churn. And once again, I just want to mention that I regularly stream on my own channel, Carl24K Data Science. So if you're interested in learning more about not exactly this subject, this is only one chapter. So it's not even a great example of what the rest of the book is about. Again, this is the book, Fighting Churn with Data, that all this material comes from. Chapter 2 is on calculating churn because you kind of have to get done with it at the beginning. But in a way, it's just kind of like bookkeeping. And the rest of the book is, to me, much more interesting. But anyway, this is what we're doing today. So next is activity churn. Activity churn is actually what you use when you have no subscriptions. Because if you were here at the start of the stream, I mentioned that the concept of churn applies to ad-supported and in-app purchase-based products, but ad-supported and in-app purchase-based products actually don't have a subscription. So what do? You may remember that at the start of the stream, I said that the product has events. So here you can also define churn based on the events that a customer has. So this is just like an illustration on a timeline of events for one customer. And there can be breaks in the events. If the customer takes a short break, meaning they don't use the service for like a week, then that's not a churn. But let's say, shown here on the right, the customer goes missing for some months. Then you count that as a churn. And the number of months that you think a customer should go missing for to consider it a churn really depends. It can be different for every business. Maybe we should illustrate the events again for anyone just joining. What do I mean by events? Let's go back to the SQL, and I'll do actually a new query. We'll just do select star from events, limit 100, order by event time. I think there's an event time field. Oh, it's not select star. Oh, I think the limit, that's the problem. Limit has to go after order by. You'd think I'd know that by now. What? Select star. Wait, I don't have an event table? Maybe I haven't like set my schema. Let's do this one. That sets the search path. So now this should work. There we go. All right, so here are some events. Whoops. Why no events? Oh, it's just event. That's my problem. Duh. See, don't even remember my own things. Okay, so this shows you events with the event type ID. Actually, let's go back and look at them with the event type, just for anyone who didn't see this earlier. Let's see, is this the right one? All right, so here's the actual sequence of events. Let's actually look for one account. So account 1372. We'll add a where clause. Account ID equals 1372. So this is actually the stream of events for one account. And you can see that on January 1st at 1:09, he had a like. And then at 1:45, he made a post. And at 3:22, he made a dislike. And these events continue for days, for this customer. Let's see, when 1372. He's still going on January 8th. So maybe we should just like take away the limit and see how many events one customer had. Looks like 2,729 events from January 1st up to June 30th. Wow, it looks like this customer doesn't even churn. But anyway, that is the background data here. So each customer has a series of events, and you can define a churn based on activity as whenever the customer goes missing for a while. And that could be 30 days, 60 days, 90 days. It depends on your service, and you have to set that window based on your own service. And you typically set it to a length of time just so that when a customer goes missing, they don't come back. So there's more about exactly how to choose that in the book, but let's actually just go to the code and look at it. Now, going back to the code, I think actually I have to make a new run configuration, which I'll do right now. This illustrates how to make a new run configuration. You just copy, and I'm going to call this one listing 2.3, and now I'm just going to change the listing parameter to 3. And now that's my new configuration for running listing 2.3. Again, if you want to find listing 2.3 in the code from the GitHub repo, there's a listings folder, chapter 2 folder, and then listing 2.3. I'm going to run the SQL, and then we'll take a look at it. All right, that one just ran. It's actually taking a minute to run. Actually, note this. Let's watch how long this one takes to run. It's a little bit longer than the others. Why does it take longer to calculate churn from activity instead of churn from subscriptions? If you're here at the beginning of the stream, I mentioned that subscriptions are generally small data because every account only has one subscription per month, maybe a few. All right, so the SQL finally ended. So it took a lot longer to calculate churn from activity because the event data that you use for activity churn is actually big data. You've got a lot more events. Earlier in the stream, I did count star, and I think there's something like 15 or 20,000 subscription records and 17 million, maybe it was 100,000 subscription records, but it was a lot less than events, which are 100 million. All right, I'm going to copy this SQL out to the SQL GUI again so that we can mess with it. At least a little bit. I got to mess with every SQL at least a little bit, or I'd just be like, this isn't just a demo. So let's see if it runs. Oh, it's going to take a while again. I'll run it and we'll see how long it takes, and then I'll start showing you. So there's one more parameter. I say it's a parameter, but there's one more sort of definition in my first CTE, which is the interval. And here it's defined as 1 month. So for this calculation, I'm saying a customer who's gone dormant for 1 month, we call that a churn. Then you still do the same basic approach as the other churn calculations, where you have start accounts in one common table expression and end accounts in another. All right, the SQL completed. We got a 6% churn rate, 94% retention rate, shown down here. But back to how we select the accounts. Now instead of using the subscription, you say an account is active if they had any event within a time range that is less than the start date and greater than the start date minus 1 month. And then we can count them. And then for the end accounts, we do the same thing. You select accounts that had any event within the end date, less than the end date, and greater than 1 month before the end date. So my interval was defined above as 1 month. Then the rest of the churn calculation is actually similar to what you already know. We do the left outer join between the start and end accounts. So you basically take all the accounts from the start table, join them with accounts on the end table, you fill in nulls for any non-matching accounts, and then you only take the non-matching accounts because those were your churn accounts. And I explained this outer join earlier in the stream, so I'm not going to beat it to death. So actually, other than the way you get the start and end accounts being different, the activity-based churn is the exact same calculation as the regular churn. And again, you would use this mainly for a product or service where you didn't have subscription. So this is the final calculation. The number of churns divided by the number at the start, or retention is 1 minus the number of churns and the number at the start. And here you can see the number at the start was 10,964, and the number that churned was 672. Now those numbers are a little bit different from the standard churn calculation we did based on subscriptions. And I think that's just like an edge effect. At this particular date and time, maybe a few of those people a few of those people might have not churned yet by activity on the exact date versus the subscription date. So it's just off by a little bit from the regular churn. But normally you would use activity churn when you actually don't have subscriptions, because if you have subscriptions, you just calculate churn from that. It's faster, and it's also the official churn, because someone might have stopped using your product, but if they still haven't canceled their subscription, they're technically still a customer. In future streams, we'll look at the fact that when someone stops using their product, they're probably right about to churn. So again, activity, churn and subscription churn end up being the same. And if you want to see more of those future analyses, if you didn't hear already, I have my own Twitch stream at Carl24K Data Science, shown here on the bottom. So in future streams, I'll be going through the entire book, Fighting Churn with Data, And we'll be doing all that kind of analysis where you really figure out who's going to churn and why. But for today's stream, I'm going to wrap it up with one more topic, which is time period conversion. So time period conversion, let me ask you, you can have annual churn, which is how many customers churn in a year, and you can have monthly churn. Now, the number of customers that churn in a year may well be 12 times the number that churn in a month, but is the annual churn rate as a percent 12 times the monthly churn rate? All right, does anyone have a guess? Anyone out in the, anyone on the chat? No, is annual churn 12 times monthly churn? The answer is no, it's not. If it was 12 times monthly churn, I wouldn't have a whole section in the book and on the stream to explain why. So now I'm going to try to quickly explain why annual churn is not 12 times monthly churn by looking at a survival toy problem. So this is a survival problem, and that's why you don't do, those simple churn calculations of just annual versus monthly. You actually have to look at what happens. So let's look at what happens in a survival, from a survival point of view, meaning how many customers are left. This is a simple example. If you have 100 customers at the start, shown here, month 1, and suppose you have a 10% churn rate, to make the math simple. So in 1 month, 10 customers churn, and at the end of the month, you're left with, well, this is kind of showing the math, you're left with 100 minus 10, or 90, which is the same as 100 times your 90% retention rate. So at the start of month 2, you've got 90 customers, which you can see is your 90% retention rate times the start. Then you still churn at a rate of 10%. So that actually, because churn, remember, is a rate, not a number. So the churn rate is still 10%. So in the next month, you lose 9 customers, not 10. That's the key to being a rate. And that's actually equivalent to, if you go all the way back to the start, you had 100, and then you had 0.9 retention from your first month, and then your churns are 0.1. So your new result at the end of month 2 is 90 minus 9, or 81, which is equivalent to 100 times the retention rate squared. That's what I'm showing down here in the second end account equation bubble. So you can kind of see where this is going, but just to beat a dead horse to death, although don't beat horses, I am like pro animal rights. So when I say beating a horse to death, I do not mean that anyone should beat horses. Be nice to horses, they're great animals. Anyway, at the end of month 3, you had 90 minus 9, or 81 customers, which coincidentally is your retention rate squared times the number of customers at the start. So you can kind of see where this is going. There's a lot more math in here, but the end result is that each month you multiply the remaining customers by your retention rate in that month. And that's what's kind of shown here, or the end accounts. At the end of the first month, it's 100 times 0.9. At the end of the second month, 100 times 90% squared. At the end of the third month, 100 times 90% cubed. And at the end of a year, you would have, if you had 10% churn each month, you would have 100 times 90% to the 12th, or just 31 customers left. So that is the illustration of the survival process for customers churning. Now this is like showing it in a toy problem. Next, I'll show you the same thing in a set of equations. So you start out with n customers in the first month. At the end of the first month, well, you churn out C, which is the same as ending up with n times r, doing this little algebraic manipulation here. Month 2, you start out with retention r times n, and you end up with nr squared. That's your start from month 3. Then you churn out churn rate times what you started with, and if you do this little algebraic manipulation here, you end up with nr cubed at the end of the third month. And lastly, keep on iterating this out. Eventually, you'll get to the result that after 12 months, you have nr to the 12th customers left. So this is showing for retention. Actually, we haven't even talked about churn yet. So this is the survival of customers after 12 months if you have a monthly retention rate of r, small r here, starting with n customers, after 12 months, you have nr to the 12th. So that is the survival analysis of your churning customers. Now, what about calculating the churn rates? Let's now look at the monthly or yearly churn scaling. This shows you that I just showed you on the last slide that retention after 1 year is retention after 1 month to the 12th. That was because you start with n customers, and after 1 year, you have n small r monthly retention to the 12th. Now, what does that mean? You can then do churn 1 year as 100% minus retention 1 year. And that was one of the basic churn retention relationships I showed earlier on the stream. And that means further that churn after 1 year is 100% minus retention after 1 month to the 12th. That's just substituting in the first relationship. So I didn't warn everyone, but there is a little bit of math in this. So I hope the math, doesn't bug people too much. But yeah, there is a little bit of math when you do churn calculations, especially when you scale them. All right, so we're basically there. So now we can say that churn after 1 year is not 12 times churn after 1 month. It's actually 100% minus 100% minus churn in 1 month to the 12th. So I actually say this as 1 minus quantity or 1 minus churn to the 12th. So this is the equivalent of your 1 month retention rate here. You take that to the 12th, that's your 12-month retention rate, 1 year retention rate, and your 1 year churn is 1 minus your 1 year retention rate. So that's how you do churn scaling from 1 month to 1 year. If you started out with your 1 month churn rate, this is how you would get your 1 year churn rate. Then you can also turn it around, and if you start out with your 1 year churn rate and you want to get your 1 month churn rate, you actually use the same equation but with the 1/12th power. And that means that's the 12th root. If you know what a square root is, that's the second root. This is the 12th root. Now, don't worry thinking about how do you calculate a 12th root? Well, you just do it with code. In code, it doesn't matter if you're calculating a square root or a 12th root. It's basically the same code. So this shows how you get from churn in 1 month or churn in 1 year to churn in 1 month if you want to go the other way. And don't worry, we're going to get to the code that does this in just a minute. But first, I just want to show you the arbitrary churn scaling. Because in my code, I don't actually do 1 month, 1 year. I say for any time period you measure at, let's say you measure churn over n days. So if you measure churn in n days and you want the equivalent 1 year churn rate, you use the same equation, 1 minus the churn you measured, but now you take it to the 365 divided by n. Do a simple example. Let's say you measured your churn rate in 60 days and you want the 1 year churn rate. You actually take that, the retention goes to the 6th power because 60 days fits in a year approximately 6 times. So that's an example of if you measured churn over 60 days and you want your 1 year churn rate, this is the equation you would use. And this is showing you if you measured churn in some number of days and you wanted your monthly churn rate, you would do the same trick kind of here, but you do 365 over 12 is the average number of days in a month. I think it's 30 point something. And then that is your power, that number of days in a month divided by n. So for example, if you measured churn in 90 days and you wanted the 1 month churn, you would take that, the equivalent retention rate, to the 1/3 power or the cube root. So this is how you do arbitrary churn scaling to any time period. All right, finally, let's go to the code. So this is in listing 2.5 from Fighting Churn with Data. And if you didn't see before, you get the code from the GitHub repo. Then there's a listings folder. You go to chapter 2. There'll be listing 2.5, which is, I call it the churn rate scaled. And by that, I mean, scaling it by time. I'll make a new run configuration here as usual. by duplicating my old run configuration. I'll just call it 2.5. This is all using PyCharm. I went over this in last week's stream, there's instructions for using this on my README. I actually give my own instructions for PyCharm in case anyone's never done it. I just wanted to make it easy for people to get started. I assume if you're using some other Python development environment like IntelliJ or VS that you know how to set it up yourself. I can't provide instructions for every, Python environment. So let's look at the scaled churn. Once again, I'm just going to run it. We'll get the printout, and then I will take the printed code here, printed by the wrapper program, has the bind variables filled in with dates. So I'll take that code back to my SQL GUI. I'll run it here, and then we'll take a look at how it's different. It actually starts out exactly the same as the others. But note here, I'm now calculating my churn over 3 months from March 1st, to June 1st. But the start accounts is the same as the SQL queries you saw earlier in the stream. We select the starting accounts by looking for subscription start dates less than or equal to the calculation start date, and the subscription end date has to be greater than the calculation start date, etc. This was all earlier in the stream in case you missed it. I don't want to go over it too much. Once again, we calculate the number of churned accounts with a left outer join and the where condition that the ending account ID must be null, because we want to select out the accounts that dropped out, not those that stayed, which would have been the accounts that stayed is given by an inner join. We also did that earlier in today's stream too. So finally, at the very end, this is almost like the original query. A little hard to read it here. Not really lined up. Let's see if I can clean this up. Maybe if I make the font smaller, I think it'll actually be easier to read. All right, so we've got the number at the start, the number that churned. We also have the number that churned divided by the start, which I call here the measured churn. So the measured churn is how many that actually churn. And in this query, it's in a 92-day period. You can see here, the next thing, I select out all these components of the query to make it clear. So the end date minus the start date is 92 days. And then to calculate the annual churn, as I explained in the previous slide, we take, it's 1 minus this power, 1 minus the number that churned divided by the number at the start, and now we're taking it to 365 days divided by the number of days, and that gives us the annual churn rate. And then the same query, remember I measured churn over 90 days, now I'm going to calculate, we're calculating both the monthly and the annual churn rate, the equivalent monthly and annual churn rate. And so this is the monthly churn rate. It's similar, but we take, like I showed, 365 divided by 12 is the average number of days in 1 month, and we divide that by the number of days in our measurements to get the exponent for this calculation. So in this case, we had 1,327 customers at the start, 10,000 rather, 10,300. 1,300 of them churn. So we measured 12% churn or 13% churn in those 90 days. But 13% churn in 90 days is equivalent to, a little hard to read this, it's equivalent to an annual churn of 42%. Because to get that, we had, you take the retention rate from those 90 days, and then they have to be retained over the entire year. So it's increases the churn rate going from 90 days to a year. So the annual churn rate for this measurement is 42%, and the monthly churn rate is only 4%. So the monthly churn rate we measured here is actually very similar to the churn that you measured with the simple monthly standard churn SQL, which we did earlier in the stream. Now, why would you measure monthly churn over 90 days? This is essentially like an average. So this 4.4% is essentially, it's exactly the geometric average of the churn rate over that period. So this is like your geometric average monthly churn. And you might want to do that just to see what's your typical churn over that period. Now, why would you want to measure the annual churn over 90 days? You would want to do that if you only have 90 days of data, but you need to report an annual churn. So let's say you only started collecting data for churn. Oh, wow, Max Payne Life. I just saw the compliments. I'm glad to hear that you're learning a lot, Max Payne Life. And I'm sorry I didn't see your messages in between all of Manning's promotion. Well, Manning's got to promote. They got to sell books. More power to them. But please follow me, Max Payne Life, on my own stream, which is on Carl24K Data Science. So let's see. So I was just saying, yeah, so you might not have a whole year of data, but you might want to know what the equivalent annual churn rate is. Or you might be only like 1/3 of the way through the year, but you want to know what's your churn rate for that, part of the year. So let's see. I think I'm really near the end. So that was the time period conversion. So yes, will do. Thank you. Yeah, so my own stream shown here at the bottom, Carl24K Data Science. I do this every weekend because I have a day job. Yay! Following me. Glad to see that you're now following. I don't actually know if these follows are following Manning or following on my stream, because it's really confusing right now because I'm streaming to Manning's Twitch stream key, but I don't know. Anyway, finally, we're at the end of the stream. I think I'm going to give you a summary of what we talked about today. Fighting churn is about targeted intervention. Sorry about that. Just had to clear my throat for the final summary. You don't want to hear me like rasping and hacking away after losing my voice. I don't know how other streamers do it. I mean, people who stream for like 10 hours. I'm like losing my voice after an hour and a half. And I'm constantly drinking my throat tea with honey. Keep me going. So anyway, fighting churn is about targeted interventions with your customers. You do things like improve your product, send out engaging emails or messages, but you don't want to spam your customers. So you really need to use your data to find out what they really value about your product. And of course, you can also support your customers with onboarding, training, or if they call up and help you. So that's the background. Today we were actually talking about just calculating churn. So churn compares lost customers to the starting customers. And that's one of the key principles of churn calculation, that acquisitions are ignored. Acquisitions meaning your new customers that just signed up or joined. All right. Churn is easily calculated for big data using SQL. Now that was what we were looking at today. Now why do I show calculating churn with SQL? Because if you have a lot of customers, you're not going to want to do it in a spreadsheet. And also, the churn calculations are very much SQL friendly calculations. It's either inner joins or outer joins for retained customers or churn customers. So that's why I really advocate churn with SQL, or calculating churn rates with SQL. The other thing to note that's good about it is you don't have to take the data out of the database. Because remember, if this is a real company that you're working on, your customer data is really very important to you. And you don't want to leave it lying around. So this is a great way to do the calculation while leaving your data securely in the database where it belongs. And you actually only extract out the result that you need. Now that's a constant principle throughout my book. Again, if you just joined, this is the book where all this comes from. But so anyway, that's why we calculate churn with SQL. All right, Michael Let's TK. Thanks for following. Love to have you come back. All right, so we learned in the stream today multiple measures of churn. Consumer products, you basically want to use the standard churn that I showed you. And I say a consumer product because that's when the customers aren't paying too different in prices. Usually consumer products, the prices are pretty similar. So that's why it's appropriate to use standard churn. For business products, you tend to have a big difference in the amount that customers pay. Your highest paying customers are going to be big businesses. Your lowest paying customers are small businesses. So that's why you use revenue churn. Now, if you want to report your churn to your investors, then you use net retention. And net retention is kind of like the glass half full version of churn. It actually obscures your churn a little bit by letting your upsells cancel the churn rate. And that's good to report to investors because it puts a positive spin on things. Also, there's a very reasonable argument to be made that net retention is actually the most important metric for investors because, the investors kind of don't care about the details. They just want to see that you're retaining the money that you get. So there's also a lot of reasons why investors want to look at net retention. And lastly, if your product is ad supported or in-app purchase supported, then you use activity churn because, you don't have subscriptions. So the standard churn calculations and revenue churn calculations are all based on subscriptions. So if you're an in-app purchase or ad-supported product, then you will use activity churn. All right, so that's the summary of the stream. Not much more to say. I just want to mention, like I've said a few times, I regularly stream on my own channel, Carl24K Data Science. My regular schedule is actually, I do Saturday morning and Sunday afternoon. And I stream on the weekends because, I have a day job. And so I can't be streaming during the week, or I think my company might be pretty mad at me if I don't watch Twitch during the day at work either. I wish. I just have too much work to do. I mean, it's just, I can't concentrate on my day job and watch Twitch at the same time. That would be cool though. Anyway, so normally you can catch me on Saturday, 9 a.m. Pacific, and that's my stream that hopefully some people in Europe can make it. Then on Sunday, I do a 3 p.m. stream, again in Pacific time. So that'll be in the evening on the East Coast. And I keep hoping that someday someone will join my stream from either Australia or Asia or something. So that's why I like to have different times so people all over the world will hopefully tune in there. So my next stream is actually, this is wrong. My next stream is Sunday, tomorrow at 3 Pacific. So I'm dumb. I didn't update my regular schedule slide. But anyway, hope you can join me sometime on one of my regular streams. And of course, I also auto-host the Manning's channel. So if you ever check out my channel and I'm not on there, you're probably going to see Manning books and other great streamers from Manning. Oh, you're from Australia? Wait a second, Max Payne Life. What time is it in Australia? This is actually morning in Australia. Cool. Yeah, it's a great time for you. Well, hopefully you can join my streams on Sunday afternoon. That's when I'll usually be, live at a reasonable time. Saturday morning, not so good. Yeah, well, my Sunday stream will be Monday morning for you. I think. Yeah, that's right. My Sunday stream will be Monday morning. Well, hopefully you can watch Twitch at work. I know, like I said, I can't. But so anyway, that's what I got. And of course, you can always, catch the save streams on Twitch. All right, so thank you for joining me today. Other ways to connect with me, follow me, connect on LinkedIn. I'm on LinkedIn a lot because this is all pretty professional material. And I also am on Twitter at Carl24K. I only tweet really about data science, churn, and what we call the subscription economy, which is kind of like the world of subscription companies and software as a service or SaaS companies. And if you didn't already, please follow my own Twitch stream, Carl24K Data Science. Over the next couple of months, I'm going to stream the entire book with kind of live examples, stepping through the code, and answering questions, making examples. Yep, 24K it's my name now because my real name is Carl Gold. as you can see. So I took the 24K thing. I just want to, for the record, I was doing this before the wrapper 24K Golden. So 24K Golden, although I do really like 24K Golden's music, I wish I could play it for you on the stream, but of course it's copyrighted. So, all right, Pauper U20, thanks for following. Glad to have you today. But so yeah, those are the ways to keep in touch. Oh, lastly, I should have mentioned, I have a blog website, Fight Churn with Data, although it's actually embarrassing. I don't think I've updated my blog in like 6 months. I've really been focused on the streaming, is the truth. I've been streaming every weekend, and I've been too busy to make a new blog post. So I'm not much of a blogger. It's honestly more fun streaming. I hope you agree. But I'll get a new blog post up there anyway. But it's also a good place to find links to not only, actually what's good on my blog site is also there's videos of my conference presentations and other things like that, and links to everything. So again, thanks a lot for joining today. Hope you found this interesting. Yeah. So have a great rest of your weekend. I've really enjoyed streaming with you here. It's been fun being on Manning's channel. I had it figured out a lot better this time. I streamed on Manning's channel a few months ago, and I just didn't really know what I was doing. So I think this will be a much better stream. So, all right, I'm going to call it a day. Thanks for joining. Like I said, enjoy the rest of your weekend. I hope you had a good time, and I'm out. Thank you, Max Payne Life. I hope I see you on my stream tomorrow afternoon, which will actually be a good time for you. So take care. I got to go enjoy the rest of my weekend.